Video attachment number 1 to the European format Curriculum Vitae or similar. Three, two, one, go. Nearly around the beginning of 2013, starting from a pre-existing basic exposure to 3D graphics and game engines, I became interested in particular into a branch of this, which is terrain rendering. Since at the time I had already grown a certain interest in algorithms in general, my first aim was to choose a terrain rendering method that be interesting both as an algorithm and be at the same time good as a terrain rendering method itself, obviously. But more precisely, I wanted that it be a rendering method which is best for real geographic data, or at least in drawing terrains which at least look somewhat natural. So I went on to gather some information, some very superficial description of the various terrain rendering methods, and the method by Peter Lindstrom and cooperators, method published in 1996, attracted immediately my attention because it was a terrain rendering method just fit for my tastes. Of course, among various terrain rendering methods that I got some information about, this was the most difficult and also most tricky, but I decided to favor this method anyway, because being a person with a very practical mentality, I appreciated very much the fact that this method doesn't just stop at using a hierarchic representation of the level of detail in the various areas of a terrain, but it combines the hierarchic representation and a special geometric scheme itself intrinsically hierarchic, and goes very much in depth with the combined usage of these two things to produce finally a terrain rendering method whose basic theory handles completely the problem of terrain rendering, including the fact that usually a terrain which one wants to draw is based on real geographic data, or seems to some extent a real geographic area's height map, and that was the point why I favorited it. The main idea was that this method is maybe the only one which is very contour friendly, where of course contour in this case I mean those real geographic lines which appear if let's make a practical example. One looks at a satellite image and applies some strong contrast to it, and some more sharp or more wide or more pronounced or less pronounced lines appear. Those, I mean, are geographic lines, and they have a specific geometric meaning which this scheme and hierarchic data structure put together according to this method can be defined. There wasn't much documentation about this method. So of course the safest thing to do was to write it from zero. In fact, I wrote it in the C++ programming language from zero, after having understood at least to some extent the theory. After a first implementation, I was able to clarify most of the things left unclear by the documentation I was able to get about this method, and when there were no doubts anymore for me about this method, I adapted it, implementing a procedure that be optimized for real geographic data, even more than the original method, and that it be particularly sharpened to be run, let's say, in background thanks to multi-threading. Okay, of course, one of the problems of this method was that besides being the most complicated, tricky, and also long to write to implement in a programming language such as the C++. The other problem was that it did lots of operations. In order to do an update of the level of detail in the different areas of a terrain to draw, it took to the program more than 2 or 3 seconds on a modern computer, even if paradoxically one of the absolutely strongest points of this whole method was that a change, even a quite abrupt change in the level of detail in a certain area of the terrain, doesn't produce too much disturbing visual artifacts, due to the fact that this method is one of the very few which can preserve the contour lines. So at that point I had to put some creativity at work and make some theoretical and practical research to develop a variant of the method such that it allows some smaller visual artifacts, that is abrupt pop-up of detail, instead of being perfect as the original method. But so that the modified procedure be only, okay, not so perfect, but roughly very good, so that it be good for large terrains, even as large as 2048 by 2048 height samples, and that it be implemented as a procedure that can be ran at smaller chunks of operations, so that one can run it, so to say, in background, and when the update of the level of detail is ready, is ready. Modifying the procedure so that it be, as I tried to say it before, a procedure which can be ran at let's say smaller stages of operations, so that it can be ran in the context of a program which does lots of other things, and there isn't any need for the level of detail of the terrain to be updated always, but just once now and then, like every 3 or 4 seconds, and so on. That was quite straightforward, even if not easy, but it was mostly programming. And I did that, and it was fine, but of course it was still the original method, but with updates of the level of detail which happen more seldom. It was still the original method and was heavy, couldn't do larger terrains because that was the original method. And here some modification had to be done to the basic idea underlying the whole method. Fine, going on from here was easy, because this method went very in depth with the very concept of a surface, and what kind of surface real geographic terrain is, and here and there. Of course, it had lots of properties, and it was sufficient to dig a little bit into the many properties of this scheme and find out how to adjust the method so that, for example, it can do a preliminary analysis of the terrain to render later, eliminate some unnecessary details with the possibility maybe to adjust to if remove only those absolutely unnecessary or remove also some others with some adjustable tolerance, and then to do the dynamic change of level of detail according to the position of the viewer with respect to the terrain and so on. And what you see here is the final result of this
2048 by 2048 height samples terrain. The geographic lines naturally erasing are clearly seen here. They can be thinner, wider, and they can be more stressed or less stressed. The strength of the method lays in the preservation of the naturally arising contour lines. Thanks to this, even a quite strong variation in the level of detail in a certain area of the terrain produces only moderate visual artifacts. Artifact by which I mean abrupt pop-up of geometric detail. Of course, the larger the terrain, the slower it takes for the program to produce an updated level of detail for the terrain. Here, the ability of the procedure to preserve the geographic lines is seen. Let's see a smaller terrain. Wireframe visualization. Now solid visualization. Each of these squares of the texture represents the smallest variation in the local height of the terrain, which can be represented by the program in those areas of the terrain where there is the maximum level of detail locally. That was the purpose why I kept on purpose the texture resolution at such a low level. So it can be clearly seen how much information is being processed in real time by the program, by the method itself, according to the flavor of it which was implemented here, which is able to illustrate, I think, I hope, the strength of the method and of the implementation here. For such a small terrain, of course small comparatively, it is able to produce an updated level of detail quite often. You can see 2, 3, 4, 5. And so the final result is excellent. Each small packet of operations that this implementation does at each program cycle, which, for example, let's move the camera and makes the camera move smoothly ahead, is almost always the same number of operations, with some little tuning further. Of course, it could be made to be even more, always deterministically the same number of operations. But thanks to the strengths of this method itself and of the implementation of it here presented, it's evident that it's already fine, and one can quietly jump in a program that has to do many other things the update, running the update procedure every cycle, because it's sufficient that the level of detail is updated every 5 or 10 seconds, accordingly, of course, to how small these unit length squares, little small squares are, those of the texture here, with respect to the speed, the maximum speed of motion of the camera, of course, and according to the maximum relative height which is reached, considering that when the height is somewhat low, such as here now, some visual artifacts can be hidden by the very point of view itself.
So, after this experience, I've always spared some time to commit to algorithms, not only those related to numerical methods, with particular regard, of course, to optimization and exploitation of multi-threading, but to algorithms in the more traditional sense, for example, graph algorithms. At the time, I didn't go further with investigation and enhancement of this flavor of the method, but of course I realized that the quite simple and we could also say brutal criterion to decide whether a certain point should be included in what is going to be rendered or not could be enhanced to more sophisticated criteria, such as, for example, that of the original method, which is completely view-dependent. Of course, without repeating here in this short presentation how it works. Or I also thought to try out some so-and-so brutal criteria, which are a little bit more similar to the view-dependent fashion, but are much more brutal, and so they need much less calculations to be done. But I didn't go further because it was clear that the hardcore thing was done, and evolving in any direction from this could have been a matter of detail. This terrain rendering method as implemented here can be used very well also in multi-threading, to try to do it really in background, and that's something that I did, for example, in a video game which is yet work in progress. There the textures are much higher and some small vegetation is on the terrain, which makes it look a bit more human. Having found at the time very few documentation about this fantastic approach to terrain rendering pioneered by Peter Lindstrom and cooperators, even considering that more than a decade passed after the publication of that method, so in order to help others to find more detailed and also more humanly accessible, easy to understand documentation accompanied by a very easily comprehensible C++ source code, I did a video tutorial about this. That's I did in Italian, and that was an important step, because of course helping others is a very important thing. Well, I think it's absolutely in place to make in the future some similar tutorial also in English, where I wish to present then also some further variants of this solid hardcore based terrain rendering.